Today we're going to do section 1.5, describe angle pair relationships. There are learning objectives. Complementary angles are two angles whose sum to 90. Supplementary angles are two angles whose sum to 180, a straight line. Adjacent angles are two angles who share a common vertex and a side. An example of complementary angles. Adjacent would be this is 30, this is 60. And then to show it's a right 90 degrees, you put a little box. That's an example of adjacent complementary angles. They share a common vertex. This is the vertex, and then this side, this line right here is a common side. It's common to this angle and it's common to that angle. That's an adjacent example. And then again, the non-adjacent angle, you could have a 30 here, and you could have a 60 here, and they're non-adjacent. Sketch example of supplementary angles. Adjacent. Okay, so adjacent supplementary angles, you could have, this is 45, and this is 135. They have to sum to 180. Those are adjacent supplementary angles. Non-adjacent. Non-adjacent would be, this is 45. This is 135. They're non-adjacent. All right. Any questions there? Okay. Identify complements and supplements. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Let's do complementary first. Give me a pair of complementary angles. Right. Even though they aren't adjacent. How did you know they were complementary? They add up to 90. Right. They have to add to 90. So we take angle BAC and angle RST. Those two angles sum to 90. Right? Supplementary. Somebody else, give me a pair of supplementary angles in that picture. Christian, why don't you give me a pair of supplementary angles?
DAC, and angle DAC, and angle ABC. No, that doesn't. Angle DAC and RST.
Yes, an angle RST. They sum to 180. Good. Okay, adjacent. Give me the adjacent angles in this picture. Max.
Angle DAC and angle BAC.
Right, angle DAC and angle BAC. Adjacent. All right. Any questions? Okay. Given that angle 1 is a complement of angle 2, and angle 1 equals 68, find angle 2. You'll have to do quite a few questions like this. Okay. So, how are we going to do it? If they're complements.
You subtract 68 from 90. Oh, sorry.
Go ahead.
Yeah, you subtract 68 from 90.
Right, 68 from 90. Another way to think of it, if you want to think of it in terms of equation, you don't have to show all this work, but I'm going to write this just so it's clear. If we know angle 1 and angle 2 are complements, we know angle 1 plus angle 2 equals 90, right? Then we plug in angle 1, 68 plus angle 2 equals 90. So we subtract 68, like he said, we subtract 68 from 90. So angle 2 equals 90 minus 68, which is, do a little mental math here, what's 90 minus 68?
32.
It's not 32, 22. Are you having trouble seeing 2?
Yeah, I just moved over.
Okay. When he comes back, do you want to sit up here too?
That's fine.
That'd be good. Then you guys wouldn't have to move around when we do partner work. You'd be next to each other. So yeah, next class you can sit up here. That's fine. So angle 2 equals 22 degrees. All right. Any questions? But it would be fine as far as, you know how I say you need to show your work? All you would need to show on here, you could just say 90 minus 68 equals 22 degrees, which equals angle 2. That's all I would require. You wouldn't have to do all this. Angle 3 is a supplement of angle 4. Angle 4 equals 56 degrees. Find angle 3. How would I do that? Yes?
You do 180 minus 56.
Right. 180 minus 56 equals, it's going to be 17, 10, 4, 12, 124 equals angle 3. Measure of angle 3. Questions? No questions. Okay. When viewed from the side, the frame of the ball net forms a pair of supplementary angles. So these two angles are supplementary with the ground. Find BCE and ECD. Okay? So, we have to find a measure of both of those angles given these two expressions. Okay? We kind of had a similar problem on the homework on this. Max, how would you do it?
So I say 4x plus 8. 4x plus 8
Yes.
plus x plus 2 equals 180.
Correct. Right. That's the first step. Before you solve for the individual angles, we have to get x. We have to find x. So whenever you have a problem like this, you have to find x. So and like Max said, you take 4x. Whoop. You take, no, I went too far. Here we go. You take 4x plus 8 plus x plus 2 equals 180. Okay, so that's going to be 5x plus 10 equals 180. 5x equals 170. So x equals 334, right? X equals 34. Now, how do I find BCE and ECD? Okay, go ahead. What do I do? Yeah, we plug into each individual expression. I plug in I take 4 times 34 plus 8. So that's going to be 136 plus 8 equals 144. So that's 144. And then ECD, okay, it's going to be 34 plus 2, which equals to 36. So ECD is 36. I don't have room to write that out, so I'll just draw a line. And BCE is 144. Oh wait, how could I check to make sure I've done this right? Yeah, if you add these two together, they should be 180. Because you know they're supplementary. All right. Any questions? Everybody happy? Ready to move on? All right. Use the fact. Okay, this is just an explanation of that problem. We've already done that. All right, now, linear angle pair relationships. A linear pair. Here we have a picture of a linear pair. Here we have a picture of something that's not a linear pair. Here we have vertical pairs and non-vertical pairs. All right? So, in your own words, write a definition of linear pair. Think about it. From the picture of what it is and what it's not, write an example of a linear pair in your own words. Okay, who wants to share their definition? Linear pair. Okay, Max.
Adjacent angles.
Okay, I agree they're adjacent. That's true. Anybody else want to add to that? What else could we say about it? Mr. Decker, go ahead.
A linear pair is two angles who share a line as one of their sides.
Yeah, that's pretty good. Right. The other sides make a line. The non-adjacent sides make a line. That's a good definition. Here's a textbook definition of that. Well, I don't like this one. I like it better what we said. Two angles who have an adjacent side and whose non-adjacent sides make a line. This says two adjacent and supplementary angles. Okay, so that's saying it makes a line. Whose non-common side are opposite rays. Opposite rays means that they both go in, the rays go in opposite directions, making a line. But the linear pair makes a line. They're next to each other and they make a line. Is a linear pair. Okay, what about, go ahead and describe a vertical pair in your own words from the picture. Vertical pair. I should tell you more. Let's say angle 5 and angle 8 are a vertical pair. Angle 5 and 8 are a vertical pair. Angle 6 and angle 7 are a vertical pair. All right? So go ahead and write a definition for a vertical pair. Okay, who wants to share their definition? Vertical pair. Anybody? Okay, let's see. A definition for vertical pair. Two angles whose sides form two pairs of opposite rays. I don't like the opposite ray definition. Everybody understands what an opposite rays are, right? They're rays that they go in opposite directions and they form a line, right? So, two angles whose sides form pairs of opposite rays. So say 5 and 8, the sides form opposite rays with each other. All right, let's use this definition. Let's say they're two angles who share a common vertex but not a common side. I like that definition better. So they share, like 5 and 8, they share this vertex, but they don't share any sides. Right? They share a vertex, they don't share sides. We need to say more than that, though. Share a vertex, don't share. And we should say, and the sides are formed by line segments, by lines. And the sides are lines. Because that eliminates this situation here. 9 and 10, they share a common vertex, right? They don't share a common side, but their sides aren't lines. This is not a line. That's two different rays. So is that. It has to be a straight line, right? So they're opposite each other, and their sides are formed by the same lines. Okay. All right. Is it clear? Does everybody think they know what the difference, know what vertical angles are? Okay. All right. Identify all the linear pairs and all the vertical angles in the figure. Okay, let's do linear pairs first. So our linear pairs, linear pair, okay, give me one linear pair.
4, 5.
Yes, angle 4 and angle 5. Good, there's another one. What's another linear pair in the picture?
2, 5.
No, 2 and 5. It's a pair. Those 2 and 5 don't make a line, right? You got this void here where 3 is. There's another one, yes.
1 and 2.
No, 1 and 2 don't make a line, right? It has to make a straight line when I add them together.
1 and 3.
Not 1 and 3. There's a void. 2's in there. No, it's not 3. What? 1 and 4, right. These two, 1 and 4, their non-common sides form a line, right? So it's angle 1 and angle 4 are a linear pair. Vertical angles. VA stands for vertical angles. Give me a pair of vertical angles in this picture. Be careful. Remember what we talked about. I'll give you a clue. There's only one pair of vertical angles in this picture. What do you think it is?
Angle 1 and angle 5.
Very good. 1 and 5. Okay? 1 and 5, they're opposite each other. That's the vertical part. They share this common vertex, right? And their non-common sides are made by lines, right? So 1 and 5 are vertical angles. So we have angle 1 and angle 5. Their sides form a line. They share a vertex. They don't share a side, right? So 1 and 5 is a vertical angles. Any questions? All right. Very important you understand what those are. Vertical angles and linear pairs. Okay. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Let's draw a picture. That will help you create your equation. So we know it's a linear pair. That's a picture of a linear pair, right? They share a common vertex and a common side. Non-common sides makes a line. Linear pair. The measure of one angle is 5 times the measure of the other. So in terms of variables, what can I represent these angles with? One of them is going to be x, right? What's the other one going to be?
5x.
5x. What do we know about x and 5x?
They both add up to 180.
Yes, they're going to add up to 180. X plus 5x equals 180. So that's going to be 6x equals 180. So x equals 30. Right? X equals 30. Any questions? All right.
Not for sure 5x equals 150.
Oh, they want the measure of each angle, so yeah, we got to do 5x equals 5 times 30, or 150. 5x equals 150. Okay, very good. Everybody have it? All right. Oh.
All done.
All right. Let's do one more. I want to do one example with the vertical angles, just so it's clear. Make sure you guys understand. If I have vertical angles, so if I had a picture like this, okay, and I was given that this angle was 40 degrees, right? If they're vertical angles, then I know that here's A, here's B, here's C. Which letter would also be 40 degrees?
C.
David. Yeah, C. The angles across, vertical angles have the same measure. So C would also be 40 degrees. Okay, any questions on the notes?